Before we begin with number 1 on these function pattern applications, let's go over what the different patterns can be. So if we have a common difference and a common difference, then that's a power. That's going to be a power function. N represents the number of times the common difference or the common ratio is found between the x values. And D is the common difference. You could call it a sum. M is the number of times the common difference or common ratio is found between y values. And then R is the common ratio, the multiplier. So we have power for this. And then if we have a common difference and a common ratio, that would be exponential. If you had a common ratio and a common difference, that would be logarithmic. And then if you have both common ratios, that would be a combination of logarithms and exponents, which that's never used. Power types could be linear, quadratics, cube root, etc. based on n and m. Use parametric equations on Desmos to further explore how different n and m values change the graph. So for power functions, if we have a first common difference and a second common difference, that would be quadratic. If we had a second common difference and a first common difference, that would be square root. If we have first common difference and third common difference, that would be cubic. And so on. Like third common difference, first common difference would be cube root, and so on. The ones that you'll see the most, though, is linear and exponential. Linear would be a first common difference and a first common difference. So let's look at number 1. Which of the following would be best modeled by a linear, quadratic, or exponential function? A window cleaner is cleaning windows about halfway up the Peachtree Plaza Hotel in downtown Atlanta. The cleaner didn't properly clip one of his squeegee tools, and it fell from 400 feet in the air. The height of the squeegee t seconds after it fell is given below. What type of function, linear, quadratic, or exponential, would best describe the squeegee's height as a function of time? Now, it looks like we're dealing with gravity here, and that will be a quadratic function. Let's make sure by looking at the patterns. So time in seconds, we're going to be adding 1. And then let's see what the difference is for each of these numbers. 400 minus 384 would be, it'd be 16, so we're going to subtract 16. 384 minus 336 would be minus 48. And then we fill in the rest of these. So minus 80, minus 112, minus 144. Well, that's not a common difference. But there's no common divisor here either, a common ratio. So let's see if we can find the second difference. So 16 to 48, we're going to be subtracting 32. Negative 48 minus negative 80 would be also negative 32, 32, 32. So we have a common second difference. So we have first common difference for the input, second common difference for the output. That is quadratic. So again, linear would be first common difference, first common difference. Quadratic is first common difference, second common difference for the output. And the exponential is first common difference, and then first common ratio. Alright, go ahead and try B and C on your own. see what kind of functions that those would be. Make sure to show your work by showing if it has a common sum or a common difference or a common second difference. And let's look at number 2. Which of the following would be best modeled by a linear, quadratic, or exponential function? A company named Frone Phase Foundry designed a hardware for new smartphones and is offering a new employee an initial salary of $40,000 a year and will get a raise of an additional $6,000 for each year she works for the company. What type of function, linear, quadratic, or exponential, would best describe the employee's salary based on the number of years that she worked for the company? Can you determine the function? So for this one, she gets $6,000 each year after she works for the company. So that's going to be linear. And 40,000 is the original amount, so we're going to put plus 40,000. The slope would be 6,000. That's the rate of change, is how much she gets added each year. So X represents number of years, and then Y equals salary. Okay, let's look at B. A company named Phone Program Ring designs the software for new smartphones and is offering a new employee an initial salary of $40,000 a year and will get a raise of an increase of 12% each year he works for the company. What type of function, linear, quadratic, or exponential, would best describe the employee's salary based on the number of years that he works for the company? Can you determine the function? So if they add 12% of the current salary each year, that's going to be a different number each time. So that's not going to be linear. It also wouldn't be quadratic. You're going to be multiplying something each time. So it'd be exponential. And so we have Y equals the initial amount, which is $40,000, times 1.12 to the x power. It's 1.12 instead of just 0.12 because they're adding it on. They're not just getting 12%. So it'd be what they already have, 100% plus the 12% for that year. So Y is going to represent salary, and X is number of years, just like in the part A. Now, for part C, it says, which company would provide a better salary after 2 years of employment and after 8 years? So, go ahead and evaluate with x equals 2 and x equals 8 for both of these equations and see which one is better for each amount of time. Let's look at number 3. Explain what each of the parameter of each model means. A student was marking the growth of a cornstalk plant, and at least for the first several weeks, the plant's height in inches could be described by the following model, where t is the time in weeks. H of t equals 5 times 1.40 to the t power. This is an exponential model. What does the 5 represent? The 5 is representing the initial height. So that basically means when the study started, the plant was 5 inches tall. And then for II was the 1.40 represent. That's the growth factor. That basically means that the plant will grow by 40% of its height each week. B, a person purchased a new car which depreciates in value. The car owner determined the value of the car in dollars would be modeled by the following function, where t is in years after the car was purchased. This is also an exponential model. We have v of t equals 23,000 times 0.93 to the t power. What does the 23,000 represent? That was the price of the car. And then what does the 0.93 represent? That is the decay factor. So that means that the car will lose 7% of its value each year. We get the 7% by subtracting 100% minus 93%. C. A physical therapist charges an initial fee and then charges another amount of hour of therapy. The charges could be described by the following function model, where t is in hours of therapy. C of t equals 140 plus 40t. This is linear, where 40 is the slope, rate of change, and 140 is the initial fee. So the 40 represents the price per hour. And then the 140 represents the initial fee. D. A baseball is struck by a bat. The height of feet of the ball can be described by the following function, where t is in seconds after the ball was struck. H of t equals negative 16 times t minus 2.4 to the second power plus 70. This is quadratic. If we were to sketch a graph of this, it would look something like this, where the vertex would be 2.4 comma 70, and then it would be facing downward since we are talking about gravity. Now, what does a 2.4 represent? That's how many seconds it takes to be at the maximum height. And then the 70 represents the maximum height. Okay, you'll do the rest of these on your own. You're creating more exponential, linear, and quadratic models from the given information. On number 5, the first model is linear and the second's exponential. And then on B, it's linear and then exponential.